Okay, so we look at the kernel because, as I've said, this is in fact during my undergraduate years. I think a kernel as an operating system itself, because when we learn the theory on the kernel side, it's basically the operating system, but there are other functions added to it. So we have the kernel, in fact, is the core of your operating system or the core components of the OS. Uh, and that's the inner. Then we have a shell. I'm sure you are familiar with shell. So I'm not. We have certain shell on certain application. For instance, I think DOS operating system, the black and white, is considered to be a shell of your certain operating systems, as well as with um, Linux operating system. So we know that each operating systems run on a shell. It can be viewed through a shell. The basic functionalities of the operating systems runs on shell. Then after that, there are operating system services. Usually we can look at this at the control panel before of our computer if you are using Windows. But that's the outer part, meaning maintenance of a certain hardware and your application is done by the OS. So another aspects can be found on kernel is responsible for managing systems resources, including processes that will run, number of threads to be run, and the background processes will run, as well as file management system. And it also assists application with performing work. So that means the currently run applications. Tinitingnan din yan ni kernel. It's basically part of the function of the kernel. As I've said, in my perspective, sometimes when I consider OS, it's equivalent to kernel because the rest are operating services, which is also directly or interact with the kernel, because it's the kernel that will the kernel functionalities of the kernel, I mean, directly coordinates with your hardware. Also, so these are main operating systems function as of now. The file management. So that means if you look at operating system, automatic we will check the file that it will support file management of your certain a computer system. So meaning if you see Android, there must be a file management of the basic functionality of the Android. If you see Mac, there are embedded systems that of now which meaning tailored fit. For example, in your router, so somehow your router operating system is also tailored fit to that particular hardware. In fact, you need an emulator sometimes to run it in your computer, and so there is also a file management aspect. Second is application management, meaning applications that will run within your operating systems, built-in utility programs such as disk cleaner or other built-in utility that will help the operating system function, such as before we had trash bins, automatic file over automatically erase files or overlap the files for ano ba yun, parang automatic siya ma-delete once your reserved memory for those deleted files. So that's part of utility. Dust bin, I think dust or something like a bin before in Windows. I'm not familiar. It's still present as of now. I'm not sure if it's present. That we still have the recycle bin part of your computer. I'm not sure if it's present. And that is one of the utilities. And even your computer, your Android phone, there is a function that you will just press and it will free up some memory. So that will be part of the utility programs included in operating systems. And control of your computer hardware. That means actually the user itself, we as the programmer, we don't interact directly with the hardware. Unlike before, the father of computer, for instance, um, who programmed the 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 whole program before uses the actual wires to operate or to run their program. They are required to operate within the hardware itself through maybe punch card or other means. But as of now, we don't interact directly with the hardware. We are controlling the hardware part based on the applications that we are using or based on the operating systems that is installed in our computer hardware. Also, there are general types of operating systems. I'm sure there are a lot of operating systems types that you can enumerate, but this one is one approach. We have a multi-user. That means two or more users work with the computer at the same time. So meaning, of course, it's obvious. Second, multitasking, two or more processes running at the same time, meaning it can perform, majority of the operating system as now can perform two or more processes running at the same time. We have also the concept of multi-threading. This is two or more parts of the same processes running at the same time. That means if you can imagine, if you add numbers, for instance, it can run two threads to solve a particular problem. This is common for the high performance computing or HPC servers. They can run one problem, they can separate and run a problem. They will divide one processes into two so that the output can be easily retrieved in the earliest time. This is common for image processing and creating models especially for deep learning and machine learning. We identify how many threads a certain computer or operating system can support. I think there is also what we call as parallel computing. I'm not sure if this is an appropriate time, but I think the parallel computing, which creates programs that can run on different threads. So for instance, if you will compute the factorial, I think, factorial where the running time would be exponential, you can create threads, multi-threads. It will support threads. That means one factorial problem can be separated so that it will go along, for instance, factorial 5 plus factorial 6 plus factorial 10. So the process is not linear. So some OS will also support those types. And that's it for background on the operating systems. Thank you for your attention, and I hope that